Okay, 19. The average shed, or the storage shed, is the shape of a half cylinder of radius r and length L. What's the volume of the shed? Well, volume of the shed is half a cylinder. And a cylinder, or any right rectangular solid, is going to be the area of the base, pi r squared, times the height, which in this case is 1/2 pi r squared times the height is L, since it's laying on its side. B. Okay, now let's see. It says it's filled with sawdust whose density is proportional to the distance from the floor. That makes sense because the weight of it's going to be, it'll be heavier on the bottom, or more weight on top as it's stacked, so it'll be denser at the bottom and lighter at the top. But this is the thing to look at here. What does it mean to be proportional from the height of the floor? That means the density is proportional k times the height. Where k is some constant. K is a constant. Okay, so the density, mass per volume, is proportional to the height, equals k times h. Okay, so we'll call this d equals k times h. The constant in proportion is k. I read that, so I knew that's why I wrote k. Calculate the total mass of the sawdust in the shed. Well, you have to look at a couple things here. Let's look at this. The density is constant along this strip, right? It's actually constant along this rectangle that's inside there. Okay. So inside that, or that rectangle, density is constant. So I should be able to figure out what the mass of the of that rectangular slab is. That is delta. We'll call it delta H, is what I called it, because we're going to be going up. Let me make this bigger here. We're talking, oops, H units off the floor. This slab is delta H thick. Okay, and so the mass of the slice is the density times the area, or the volume I should say, of the slice, right? Because remember, density is mass per volume, so multiply by the volume, so the density is going to be k times h, right? I would say right over here. So the density is k times h times, what's the volume of that slab? Well, it's going to be the width times the length times the thickness. Okay, so we're going to go the width times the length times the thickness. Now the reason I wrote it like this is this L is a constant. Is this a constant, the width? No, this width is changing, isn't it? Okay, because as I get taller, the width is narrower, and as I get further down, the width is longer. But I need to write the width in terms of h. Remember, L is a constant, h is a constant, and k is a constant. Okay? Well, I'm sorry, h is not a constant. H is my height here. So I'm going to write it in terms of h. Well, this right here, let me blow this up here. This is r, this is h. So how long is that strip right there? I'm sorry, I have a different color. I'll have to work on that. See if I can't move that. Okay, so I've got this triangle that's sitting in here, where this is h and this is r. So this side right here is the square root of r squared minus h squared. Right, Pythagorean theorem here. So now I've got k times h times the width of this rectangle is 2 times r squared minus h squared times the length times delta h. That's the mass of the slice. Alright, now if I want to add up all those masses, so the total mass is going to be the integral. H goes from 0 all the way up to r of k times h times 2 square root of r squared minus h squared times L dh. Okay, so let's see if we can do this. Everything's in terms of our variables. I know it doesn't have numbers, but just keep things straight. Our variable is h. That's it. So I can factor out a 2kl, and I just have the integral 0 to r of the square root of r squared minus h squared times h. This h, I'll put the h in front. dh. Okay. So now, how do I integrate this? H is my variable, r is a constant, so I'm just going to let u equal r squared minus h squared. See, this is one you obviously can't do on your calculator. So the derivative with respect to h, well, that's a constant, so that's 0, minus 2h dh. Okay, so I'm going to go ahead and put in a, let's see here, a minus 2, and take out a minus 2, or negative 2 I should say. So this becomes negative kl, the integral, negative 2h dh is du, and this becomes u to the 1/2. Got to fix my limits. If h is 0, u is r squared. If h is r squared minus r squared is 0. Don't let this freak you out, just keep working it. Minus kl, the integral of u to the 1/2 is u to the 3/2 over 3/2 from r squared to 0, which is minus kl times 2/3 times, I'm going to plug in 0 to the 3/2 minus r squared to the 3/2. Okay, I can factor the constant out like that. So this becomes negative 2/3 kl times 0 minus, the squared and the 2 cancel each other, minus r cubed. So I end up with 2kl r cubed over 3. That's the total mass. And do we have units in this problem? No, we did not. So I come down here, and that would be the mass, kilograms or whatnot. Okay, so tough problem, but at the same time, just keep it straight. Always find the mass of a slice, and then integrate to find the total mass. Alright, good job.